Naming alkenes and alkynes, we're following the same basic pattern. We're going to use the ending "ene" to indicate a double bond and "-ine" to indicate a triple bond. Sometimes there's more than one double or triple bond. So 2 double bonds would be diene and 3 would be triene. If there are double and triple bonds present together in one molecule, then it can be an enine. They're just being consistent with the suffixes. I don't know that we'll name any of those, but just so you know, they're out there. Again, we're going to look for the longest chain, but now the longest chain has to include both atoms in the multiple bonds. So here's an example. There's a double bond between these 2 carbons. Both of those carbons have to be included in the longest chain. And so this would be 1, 2, 3, 4. 1, 2, 3, 4. No matter how we number it or count, that's going to be 4. It's going to be named as a butene. Couldn't we find a longer carbon chain? Yes, we can find a chain of 5, but it doesn't include both carbon atoms of the double bond, and so we can't use that. The longest chain has to include the double bonds, or triple bonds, if that's what we're looking at. And then we're going to number that chain. So we give the multiple bond, whether it's double or triple, the lowest numbers. And we're looking at the first carbon of the double bond. So numbering here, 1, 2, 3, 4, 5, this double bond starts at carbon 2. If we number from the other end, the double bond starts at carbon 3. And so we will choose this one instead. If there's a branch, like on this one, just looking at the carbon backbone, we could number from left to right. The first carbon of the double bond is carbon 2. And if we number it the other way, the first carbon of the double bond is number 2. And so either way is fine in terms of giving the double bond the lowest number. But then we have this methyl group. If we number from the right, the methyl group will be on carbon 3. If we number from the left, the methyl group's on carbon 2, and so this is better. So the double or triple bond gets first preference, and then the substituents get the next preference if you have to decide between your numbering schemes. We indicate the position of the multiple bond using the lower numbered carbon of that bond. So in this molecule, the double bond is between the end carbon and the second carbon in. And when we're numbering this, we're going to call this 1-butene. We're identifying where the double bond is. It starts at number 1. We're not going to call it 2-butene because that would mean the double bond was between the second and third carbon. If we have more than one multiple bond, we're going to go with the one that has, again, we're going with the lowest numbers. So this one has a double bond on the end, and so we want to number from the end closest to the double bond. We don't want to number the other way. This would be 2 and 4. This is 1 and 3, and so that's preference. If you have double and triple bonds, the double bonds are more important than the triple bonds. So we have these overall ideas that we have to have the longest chain, and we number it in a way to give lowest numbers to the most important things. And so we're introducing some more groups in here. It'd be a little bit like, what would it be like? Like maybe in your family, the older people get to go first, but then how do you decide among the older people? Is it the grandma? Is it the aunt? Who's more important? It's that kind of an idea, that the double bond is more important than the triple bond. So this would be numbered with the double bond getting the 1, not the triple bond getting the 1. When we only have 2 or 3 carbons, we don't need any numbers. This is ethane. There's only one place that the double bond or the triple bond can be, right? This is ethene, and this is ethyne. This suffix tells us double bond for ethene, triple bond for ethyne. We don't need a number because it can't be anywhere else. Propane has 3 carbons. You can put the double bond between these two or between these two, but when you number it, it's going to end up the same. It would always be 1 propene or 1 propyne, and so we leave the 1 off. Once you get up to 4 carbons, then you do have to specify where the double bond is, because we have the possibility for 1 butene with the double bond on the end, or 2 butene with the double bond in the middle. 3 or 4 butene would just be an incorrectly numbered molecule. This would be 1 butyne and 2 butyne. Branched alkenes, we have to remember that we keep the double bond in the main chain. So here the IUPAC name for this guy, we have 3 carbons, that's propene, and this is methylpropene. Why doesn't that need a number? I had to think about that for a second. Because we might look at that and say, well, that should be 2-methylpropene, right? But what would happen if the methyl group was over here instead? Would that still be propene? No, it wouldn't. It would be butene, because that would extend the chain. You see that? So there really is only one possibility for methylpropene. The methyl group has to be on the middle carbon. This is 2-methyl, 1-butene. So butene, the double bond has different places it could be, and so we have to give it a number. The 1 tells us where the double bond is. So 1-butene tells us the double bond is at the end, and 2-methyl tells us where the methyl group is. 2-methyl, 2-butene. Now we've got the double bond starting at the 2nd carbon, and we've got this methyl group on the 2nd carbon. So we need the numbers here. We don't need the numbers on that one. This is 2-methyl, 1,3-butadiene, and that's where that prefix di comes in. It gets, you're making a face in the back. Yeah, it's getting complicated fast, isn't it? Butadiene is butene with 2 double bonds. And the 2 numbers, 1, 3, tell us where they are. 1 starts on the 1st carbon, 1 starts on the 3rd carbon. And 2-methyl, there's a methyl group on the 2nd carbon. I know that these rules are kind of complicated, but I dare you to come up with something more simple. You just can't. Then we can have cycloalkenes. If you just have a single double bond. If you just have 1 double bond, we don't need a number. So this is cyclopentene. If you have more than 1, then you're going to need some numbers to say where they are. This is 1,3-cyclohexadiene with a double bond starting at carbon 1 and another at carbon 3. And that's different than 1,4-cyclohexadiene. And there actually are not any other combinations that are possible for that guy.
Which one?
These are the only 2 that we're going to have. Because you never see a double bond to a double bond. You wouldn't see carbon number 2 here with a double bond going this way and a double bond going that way. Anybody know why?
It'd be too much.
what's the geometry? What's the geometry? Oh, I'm writing with an eraser. If we've got, just something out here. This is linear, right? Is this going to be okay with a linear carbon in here? It's not going to like that. And so this is not going to happen. So when we have these cycloalkenes, any double bonds that there are always going to be separated from each other because this needs to be in a straight line and that will not fit in there. Here we've got cyclopentene. The double bond gets numbered first, and then the methyl group gets the second priority. Generally, as we learn about these things, the newest thing is higher in priority than the older things that we've learned. That's usually the order that they present the different functional groups. So it's helpful to look at some examples and what the names are not. Look at this guy. So we've got 5 carbons. That's going to be pentene. And we're going to number it from this end because we care most about the double bond. We're not going to number it from the other end and give it 2-methyl, 3-pentene because the double bond is more important. So it's 2-pentene, 4-methyl, 2-pentene. If you have questions, please ask. This guy, we can get a longer chain by leaving out the double bond, but we're not allowed to do that. We have to include the double bond. The double bond's going to get the number 1 because it's on the end. We can number this way, or we can number down that way. It ends up being the same. So we've got 1 butene, and on the second carbon is an ethyl group. This guy, 4 carbons is butane. Then we change the ending to butene, but there's 2. There's 2 of those double bonds. There's an A. Yeah. We stick an A in here. See the A? Otherwise, it would look like butt dying. It's like, what's wrong? Is your butt dying? Butt dying. My kids would have a fun time with that. Kids go through this age around 3 or 4 where they think the word butt is just really, really funny. She said butt in a sentence. Yes, but I was explaining something. Oh, you said it again. So it's but, and so we stick that A in there, butadiene. I will not try to trick you with something like that. This would be 1,3-butadiene. Any questions? We'll do some examples. Name each of the following structures by the IUPAC system. So this guy right here. This is written in a condensed form with it all on one line, and sometimes that's a little hard to see. So that chlorine is actually, no, that's not working. The chlorine is attached to this carbon, and so then I'm going to just cross him out, just so I can see a little better what's going on here, right? How many carbons are there in this chain? 3. So 3 carbons is propane, right? So it would be propene because there's a double bond. Do we need to number the double bond? No. If you have 2 or 3 carbons, we're not going to number it because it's always going to be number 1. And chemists don't like the number 1, and so we don't write the number 1 unless we have to. And our substituent here is chloro, right? So chloro, propene. Does the chloro need a number? It does. When we had methyl propene, we didn't need a number because putting the methyl group on the end would change the whole name of the thing. But moving the chlorine over here or over here it would still be propene. So what number are we going to give that? 2. So it's 2-chloropropene. Let's look at this guy down here. CH3 and then parentheses CH2 3 C triple bond C CH3. Okay, so that's very condensed. Let's expand it at least a little bit. So we've got CH3, and what this means, the CH2 with the 3 on the outside, it means 3 CH2 groups in a row. So CH2, there's 1, 2, 3. It's just a space-saving thing. And then there's a carbon with a triple bond to another carbon, and then on that carbon is this methyl group. Why don't these carbons have any hydrogens on them? Because we have the triple bond on one side and a single bond on the other. That's all the bonds they need, and so they don't have any hydrogens on them. So we need to decide how to number this. Should we number from the right or from the left?
From the right.
From the right. So 1, 2, 3, 4, 5, 6, 7. So 7 carbons. What would be the name of the alkane? Heptane. And then we change this to heptene. And no, not.
The triple bond?
Yeah.
Why wouldn't it be YN?
It would be YN. It wouldn't. I did it wrong. And I'd like to say I did that to trick you, but I just had a brain fart. And then the triple bond starts on carbon 2. So this is 2-heptine.
Why is it Y?
Because of triple bond. YNE is the suffix for the triple bond. ENE is for the double bond. And ANE means there's only single bonds. So it's like learning a code or a secret language, right? We're in the organic chemistry club and we have to learn our secret language to be part of the club. I don't know. Maybe that makes it more fun. And then, of course, we need to be able to do it the other way as well. Write structural formulas for the following. 1,4-dichloro-2-pentene. Pentene tells us the number of carbon atoms. So 5, 1, 2, 3, 4, 5. There's a double bond on the second carbon. When I'm drawing structures from names, I like to go for easy. Why make things more difficult? Number from left to right. 2-pentene means that the double bond is from the second carbon to the third carbon. 1,4-dichloro. On the one carbon, there's a chlorine group, and on the fourth carbon, there's a chlorine group. And then we fill everything else in with hydrogens. So carbon number 1 has a bond to this carbon and this chlorine. So that's 2 bonds. It needs 2 hydrogens in there. This carbon has a double bond here and a single bond to the other carbon. So he needs 1 hydrogen. This carbon has 2 bonds here, 1 to this other carbon. He needs 1 hydrogen. And then there's a gap there, so I'm going to draw the bond. This guy needs 1 hydrogen because he's got this carbon and the chlorine and this carbon, but he's got 1 more space, so he's got the hydrogen here. And then the guy on the end is CH3. And if you need to draw the expanded formula, where you've got all the lines and all the H's written out, Go right ahead and do that. In fact, I'll do that on the bottom one. Any questions about that example? So 3-hexyne. Hex tells us there are 6 carbons. So this time I'm going to draw the expanded form. It doesn't say what kind of structural formula. So this was a condensed structural formula. I could draw the expanded and that would be fine. I could also draw the bond, the line angle one. So 1, 2, 3, 4, 5, 6 carbons. Three-hexyne means a triple bond on the 3rd carbon. So that would be from the 3rd carbon to the 4th carbon. So there's a triple bond. And now that's all there is in the name. The rest of it all needs to get filled in. So each of these carbons needs 4 bonds. This only has 1, so he needs up here and over there and over there. And that guy needs 2 more bonds. This one has 3 here and 1, already has its 4, so does this carbon. But this guy needs more, and the guy on the end needs more. Just going to get those numbers out of the way. And so these would be hydrogens. Any questions? From that formula, the expanded structural formula, it would be pretty easy to do the condensed structural formula, CH3, CH2, C, triple bond, C, CH2, CH3. There are some common names that you need to know. And that has to do with these 2 and 3 carbon molecules. The IUPAC name for this is ethene, but its historical name, we call it a common name, it's still commonly used as ethylene. This is ethyne with a triple bond, and that's called acetylene. I think that's a very unfortunate name, but that's what its name is. So acetylene. So if we use acetylene, you need to know that that is actually ethyne. And then this is propene, but it's also called propylene. So at least propylene and ethylene, the difference between these two names is this has the "ill" put back into it. Acetylene, you're on your own. That one's just hard to remember. 2 of these groups have common names. This would be called an ethynyl group. If it was attached to something else, the common name is vinyl. It's a vinyl group. So this, the IUPAC name would be chloroethene, because we've got 2 carbons with a double bond, that's ethene, and it's got a chlorine on it, it would be chloroethene. The common name, it's named as a chloride, and it's got this vinyl group attached to a chlorine. So it's called vinyl chloride. I know. Do we really need these complications? Sorry, they're there. This group is called an allyl group. So this would be 2-propenyl. If it was a IUPAC name, we would call this guy over here 3-chloropropene, because here we've got propene. This is going to be the number 1 carbon because the double bond has to be number 1, 2, 3, so 3-chloropropene. But this could also be named allyl chloride. This is an allyl group. It's 3 carbons. The double bond is off on the end. I'm not going to make a big deal about those, but they could show up.